I'm at Kanika Gera, a senior product manager at Adobe. My job is to make sure the development team at Adobe is not debugging code at 2 a.m. at night. And I work on the infrastructure platform, security, and cloud native technologies here at Adobe. And I'll give it over to Alex to quickly introduce himself.
Hey everyone, thank you for having us here. I'm Alex Dobre, I'm a technical lead computer scientist at Adobe, and I was leading the effort of adopting the ROSA, Red Hat, OpenShift on AWS offering on Adobe.
So today we're going to talk about Bring Your Own CNI. Networking is a topic that is becoming increasingly talked about here in cloud native space. Networking flexibility is what we're focusing on. Now, what do we expect out of network? We generally expect the network should just work, and sometimes our use cases evolve, and what comes in default does not always help. And that is where we're evolving the Red Hat OpenShift default networking here, where we brought up our use case for Ethos, and Ethos, which is a managed Kubernetes platform at Adobe. And now I'm quickly going to talk about what we are going to cover today. We're going to walk you through why we did this, and then we're going to talk about our specific use case on why the default OVN, which comes with Red Hat OpenShift, does not work or help saving into our requirements analysis. And then Alex is going to talk about how we did it, how we implemented this, and then the architectural deep down. And then we'll wrap it up with some questions and our key takeaways. We've already introduced ourselves to you, so why does this matter? Networking, as I said, is the backbone for everything we are building. And here for us at Adobe, where we manage a fleet of clusters within Ethos in our managed platform, the OVN, which is the default OpenShift CNI, did not meet all our requirements because we serve multi-cloud, multi-clusters, and we have thousands of fleets of clusters which we are catering to across our Adobe products, which are based out on or hosted on Ethos, which is our infrastructure platform. Now, when we started looking into scaling up and looking into our requirements further, what happened was we saw that Cilium was something we might want to explore because OVN was not meeting our requirements as we were scaling. And this is where we actually brought in this concept of bringing your own CNI into the OpenShift space. Alex, do you want to add anything here to the problem statement?
No, that's pretty much the thing that drove this initiative. We wanted to have a consistent CNI across all providers, and since OpenShift came with a different one, we needed some sort of solution to bring a different CNI to an OpenShift cluster.
Okay, so standardization here is the key. Now, why bring your own CNI? Besides the analysis on our requirements and our use cases, we also wanted to make sure that provisioning our clusters and then moving for any of our internal teams within Adobe for deployment is not something that causes a headache. We wanted to have something that's standardized across. We did not want our different product teams to have and scratch their heads around different networking requirements or different networking implementations. And that is why we brought in a standardized CNI. Now, why did we move towards Cilium? That's something we're going to cover later. But our requirements, which I kept talking about, was to have better networking visibility because as we were scaling, our tenants wanted more and more observability, better performance, and a stronger security. And this all requirements were being served to us by Cilium. That is why we made the choice of Cilium. We had Hubble for observability here, and then we were also making consistent deployments with our Argus CD GitOps pipeline. As I talked about our why we brought this own CNI, I'm going to talk about our use case. As I said, we have a managed Kubernetes platform, which is called Ethos. Now, why we brought in this? Because with Ethos, we have several fleet of clusters which we are managing. We needed a declarative networking approach here. And besides that, observability was becoming a key requirement for all our internal customers because we are an internal platform. And where it was, as I said, standardization was the key. We wanted all our internal product teams to make sure that they do not have an overhead where we're not bringing in more work for these teams, and we wanted to reduce the toil. So we standardized on Cilium, and then when we moved away a little bit, diving into what the outcome was, we saw there was a reduced support overload for all our teams internally. So nobody had to scratch their heads, figure out how the networking is going to work, and then also standardizing across helped us in various ways where our tenants got better observability, which was consistent across. Now, this is why we implemented this. I'm now going to hand it over to Alex to talk about how we did this.
Thank you, Kanika. So before jumping into the actual details, let's first try to understand what Cilium is and why is it important to us. Our friends from Isovalent, now part of Cisco, were kind enough to allow us to use their diagram to present the Cilium stack. So Cilium emerged as our solution of choice because of its eBPF foundation. For those unfamiliar, eBPF allows for programmable networking directly into the Linux kernel without the need of writing additional kernel modules. That means that the Cilium security policies can be applied and updated without any changes to the application code or container configuration. One other thing that Cilium does well is the use of identity-based security policies instead of the classic IP addresses and port numbers type of network filters. As for the security policies that we keep mentioning, Cilium supports layer 3, layer 4, and layer 7 policy rules, which makes it fairly flexible to our tenant use case. Just one short example. Let's say you have one developer that needs to allow egress connectivity towards an external endpoint. What they can do is to define a DNS-based Cilium network policy with FQDNs instead of using destination IPs. One other component that we use a lot at Adobe is the Hubble observability service. We try to encourage our teams to take advantage of this feature a lot and get visuals into their namespace networking configuration, and more importantly, to self-serve when it comes to debugging their connectivity issues. Now, let's try to describe how we did accomplish this at Adobe. It was mentioned before that the default networking configuration that comes with OpenShift, OVN and Maltus, are great for most of the use cases, but for us, it wasn't simply a good fit. We needed something consistent across the cluster flat, and across all providers. To help with that, the OpenShift engineering came with a solution that allows us to provision a cluster with no CNI configured at all, the feature that we called the Bring Your Own CNI. Now, there are several methods to accomplish that. We can use the command line interface by passing the --no CNI flag to it, leverage infrastructure as code tools like Terraform, or go with the Kubernetes native declarative GitOps approach with Cluster API, Helm, and Argo CD. And this is what we did at Adobe, not just for OpenShift, but for the other providers as well. As you can see on the slide, on the ROSA control plane network spec, we can specify the network type as other. That means that the cluster will be created, we will get the control plane and the API server up and running and everything else, except that the nodes won't get ready on the cluster. You can see on the nodes how the kubelet is complaining of, you guessed it right, the lack of the CNI plugin. And here is where we get the configuration and responsibility into our own hands. We bring our own CNI. How we do that? We get the API server endpoint, which should already be available, right, because the control plane is up and running, and we use it to join the cluster to the Argo CD instance that is responsible with deploying all Adobe-specific Helm charts to the cluster's flat. Once Cilium chart is synced, and we have all the Cilium agents up and running on the nodes, we'll get the CNI plugin available. Eventually, the nodes will become ready on the cluster, making the cluster happy, allowing us to continue with the rest of the cluster setup. And this is a simple yet efficient way of coming with a different CNI on an OpenShift cluster. With that, I'm passing back to Kanika to cut to the conclusions. Thank you.
Thank you, Alex. So we've tried to keep this very, very concise. If you have more questions, we can talk about this later. But from all of this, this entire journey was not just about networking. It was also about providing freedom to our developers and our tenants. It was also actually just empowering them on how the evolution, a platform evolution, is going to look like. That's how we are doing the evolution of our internal platform. Right now, as I said, we manage a fleet of clusters on various clouds, AWS, Azure, OpenShift. Now, serving to all these clouds with different tenants, out of this entire journey, our four major accomplishments were, as I say, one, an unmatched performance. When I talk about unmatched performance, we were running near to the kernels. We were running faster. We had better observability. All our tenants with Hubble got more insights into debugging, which was very, very powerful for most of our tenants. Next, there were no security trade-offs as well. So me, as being a security product manager as well, I think what we accomplished here from a security aspect was we just didn't maintain security, we also strengthened it. And last but not the least, cost, which is a concern and it's a top priority, I think, in today's era across the board in all the organizations. So that's another benefit that came in. We reduced toil, we had a standardization across Adobe, and then there was no extra operational efficiency required for all our product teams to manage, who are right now hosting their products on the Ethos platform. With that, I'm going to wrap up and open up for any questions in the audience.
Thank you for your presentation. I have two questions. The first one is related with upgrades. Did you get any blocked trying to upgrade Cilium and Red Hat doesn't support some feature or something like that, during that process, did you feel any pain, let's say? And the second one is, how do you test the new version integrations? Do you have anything in place to automatic test and try the new features? Thank you.
Thank you. These are two great questions. So I'll start with the first one related to Cilium updates and upgrades. So there's one thing that's particular to Cilium and OpenShift. We must deploy and install Cilium versions that are certified for OpenShift, and that's a great way of achieving stability with it. We as about the feature reach of Cilium. There's one thing that's different on EKS, for example. On EKS, which is also running on AWS, obviously, we can deploy Cilium in the so-called mode ENI, which allows native routing instead of overlay. That is not yet supported on OpenShift, but I know they are putting a lot of effort into that direction as well. So that's one thing. Maybe there are others, but I didn't just recall everything. And the other question? Okay, testing upgrades. Yes, so we do test the applied security policies that we have at scale. We do test around it. We make sure that the new version of Cilium does not come with regressions. It happened before, right? And whenever a new type of issue is identified, we add it to the testing suite so that we ensure that does not reoccur in the future. One example is with with the identities. There are some Cilium predefined identities that work well on the entire Ethos ecosystem, like world or Kubernetes identities. From version to version, there are some regressions that were introduced, but we make sure that we add it to the testing suite so that whenever that comes to picture, again, we file up tickets with Isovalent and they help with fixes.
Hi, thank you. Wonderful presentation. I'm just curious, why not service mesh? Because we use service mesh extensively to make our developers' life easy and better observability and security as well. So I'm just curious, why not service mesh? Is it been something ruled out by a team?
I can take a stab at that. So as I said, we manage a fleet of clusters here with different multi-cloud providers. For us to scale in terms and the requirements specifically that we were coming in terms of observability, networking, OpenShift Cilium worked out really well for us. And second, also, I think thanks to the leadership of all the Red Hat OpenShift on their contributions toward upstream Kubernetes, this really helps us stay aligned with how our roadmap priorities work for our entire platform. So it's also, I think, about a better choice that worked out for our roadmap and our strategic alignment on how we wanted to take our platform. Does that help? Alex, do you want to add anything?
Yeah, so to respond to the other flavor of the question, I don't think the service mesh of Cilium is entirely off the table. We're still exploring it. However, it didn't serve our business needs as of today.
Okay, thank you.
One question, are you using community Cilium or enterprise supported Cilium? So were you using Isovalent directly to support in this migration, or you did it by yourself?
So we started with the community, the open source Cilium, but Adobe being a big company, we also have enterprise support with Isovalent, yes. And they helped with the adopting Cilium on OpenShift, making sure that their Cilium versions are OpenShift certified, like I said, as well as helping with the feature requests that we put to empower the use of AWS Elastic Network Interfaces, ENIs, instead of the overlay mode. So yeah, we get a sort of help with the enterprise support of Isovalent.
And another one, I got the impression that basically you are replacing OVN Kubernetes because you want to be more public cloud aligned, basically, not that OVN Kubernetes was missing features or performance, right?
Okay, so yes, it does align with our business needs for running into hybrid clouds. But besides that, also in terms of the requirements we had specifically for observability and our business requirements for security were not being met by OVM. And that is why we moved to Cilium.
Okay, thank you.
And to add to that, from a technology standpoint, Cilium's eBPF implementation is sort of state of the art, and it works very well performance-wise for us. And yeah, that's another reason we took it.
DX. Hello, great presentation. I have two questions totally unrelated between. The first one is, did you manage to actually connect two OpenShift clusters in different places using Cilium, as making the connection between the spaces or stuff like that?
You mean east-west communication?
Yes.
We do use or expose east-west communication with sort of, we have a centralized, Adobe centralized connector for not just for clusters, but for other, virtual networks. We call it the multi-cloud transport, and that works very well with Cilium. And we were able to empower east-west communications with Cilium, yes.
So the solution was outside Cilium, was actually outside OpenShift at all?
Come again, what?
The solution is outside OpenShift, not inside OpenShift, to connect clusters.
It's a mix, maybe.
Ah, that's interesting. Okay, the next question. I know that OpenShift has a lot of overhead sometimes in networking. Did you saw any overhead in the Cilium under the hood? Like when managing, I don't know, a lot of DNS services and a big throughput of traffic?
It's a great question. Yes, it happened. I imagine that you was sort of waiting for this answer. Yes, it happened to see drops, especially when it comes to DNS. Then Cilium implemented a feature called DNS proxy, and we tried to use it. That improves the DNS stability a lot of the cluster. So yeah, we sort of saw it in our implementations, not just for OpenShift, for the other providers as well.
So when you see this kind of, I know that Cilium has eBPF in technology under the hood is great. Did you manage to do actually real debugging on those dropping connections using Cilium and some eBPF programs that make it easier to detect?
I think that was with Hubble, right?
Yeah, so to answer that directly, since we do leverage the enterprise support of Isovalent, what we usually do when we saw sort of more outliers in terms of connectivity issues or networking issues, we do create a Cilium system. We send it to Isovalent, and they have all the tools to analyze it and come back with the exact issue that's encountered. For like easier things, we do use Hubble to try to detect like common problems.
Okay, thank you, Irvan.
All right, thank you.